Hello everyone, welcome back to the Red Team training series. In this video, we are going to be taking a look at performing privilege escalation on Linux targets. So we are going to be continuing, from our initial exploitation phase on our Linux target, which was essentially a server that was hosting a WordPress website. And we have already established our initial access. So we're going to be taking a look at how to obtain root privileges. After which, in the next video, we'll be exploring the process of setting up persistence so that we don't lose our access. However, in this video, we will be focusing on various privilege escalation techniques native or relative to Linux systems. So firstly, we'll talk about local accounts, and I'll get to these techniques shortly. Secondly, we'll be taking a look at how to exploit SUID or sudo permissions in order to elevate your privileges. We'll also take a look at how to utilize kernel exploits in order to elevate your privileges. So let me just delve a little bit into some of these techniques and how they can be used to elevate our privileges. So when we're talking about local accounts can be used to abuse or elevate privileges and harvest credentials through operating system credential dumping. Password reuse may allow the abuse of local accounts across a set of machines on a network for the purposes of privilege escalation and lateral movement. So the objective here is to, again, identify local accounts that are running on the target system or the target server, and then obtain their credentials. So again, that can be used to maintain access on a system, legitimate access, of course. And secondly, it can be used for lateral movement. However, we will actually delve into this in the practical section. Before we do that, let's take a look at some of the other techniques. So SUID and sudo permissions. So an adversary may perform shell escapes or exploit vulnerabilities in an application with the set user ID or set group ID bits to get code running in a different user's context. So a SUID binary or SUID is a permission that can be applied to specific binaries on the target system by an administrator. And what this essentially allows is it allows ordinary users or unprivileged users on the system to run that binary with root privileges without having to authenticate with the root password. This is very useful because administrators may want to provide certain permissions, certain pseudo permissions or root permissions to a particular user only for a specific binary, as opposed to providing them with root permissions on a larger context, in that they can utilize root permissions to run a variety of commands. In this case, SUID permissions essentially limit the sudo or root privileges to one binary. And when we talk about sudo permissions, the administrator can also provide or add permissions for a particular binary for a particular user. So for example, they can set up they can essentially set up a system where a particular binary can be launched as sudo or with root privileges by an unprivileged user without having to provide the administrator or the root password. So we'll take a look at how to exploit that. And then finally, we're going to explore kernel exploits, all right? So adversaries may exploit software vulnerabilities in an attempt to elevate privileges. The exploitation of a software vulnerability occurs when an adversary takes advantage of a programming error in a programming service or within the operating system software or the kernel itself to execute adversary-controlled code. So this is not really exclusive to the kernel itself. You can also find vulnerabilities in software or packages that are installed on the target system if they can allow for elevation of privileges. In this case, we'll be focusing on kernel exploits that allow us to elevate our privileges. So we'll be taking a look at that. All right. That being said, in regards to the MITRE ATT&CK privilege escalation techniques pertinent to Linux, these are the techniques we're going to be focusing on. So local accounts, SUID binaries, and sudo permissions, as well as kernel exploits. That being said, we can actually move on to the practical aspect of this video where we'll take a look at all of these techniques. So I'll see you back on my Kali VM. All right, so I'm back on my Kali VM and I've logged in via SSH to the target. So if you remember in the initial access or the initial exploitation video where we essentially exploited this server and were able to obtain initial access, our access vector was via SSH because we had obtained the credentials for this for the user Michael. So our job now is again to elevate our privileges to that of the highest user or to the user with the highest privileges. In this case, we were able to identify that the only user that has root or administrative privileges is the root user. So that is our objective. Now I'm going to be covering a few techniques here that you should actually follow through whenever you're performing a red team engagement on a Linux target. So the first thing you want to do is, for your current user, you want to try and identify whether this user has a bash history file. Now, again, a bash history file is the file that stores a history of all commands that have been entered within the user's bash session, right? So in this case, we know that this particular user is using a bash shell as their terminal, as their default shell for their terminal. So again, you can also verify what shells are installed or set up on the system by typing in cat etc shells. You can see you have all of these shells here. And then of course, if I display the contents of the password file, you can see for the user Michael, if I can actually identify him, there we are. We can see that this user will use the bash shell by default. So if we head over to the home directory of the user Michael here, and I'll just print out the working directory there, you can see it's home Michael, and I list out the contents here. You can see we don't have a bash history file, which is probably a good thing from a security perspective, primarily because again, if the user Michael has entered any passwords or anything that could provide us with additional information as to how we can elevate our privileges, all of that would be stored within the bash history file. We can also check the history file by typing in history, and you can see it looks like this. It looks like the setup here essentially erases the history, the command history of the user as soon as he logs out, and once he logs in, all of the history for that session is stored, but not for any other sessions. So in this case, this is a dead end, right? The next thing that we should be doing is, of course, searching locally for passwords, and we are searching for passwords within configuration files, within any files that may contain passwords. Now, of course, this can be done both manually and automatically. We can take a look at how to do this manually by utilizing the grep utility. So I'm just going to copy this grep command here, and again, it will be available in the documentation for this video. So what's happening here is we're essentially using grep to actually recursively go through the root file system of this Linux server and then search for the following string, which is password. And essentially, it's just going to output it into no file here, into dev null rather, and it's going to color code the results for us. So what this will do is it will display any files that contain the occurrence of the following string. So if we hit enter, you can see there's quite a lot of results being output here, and it essentially shows you all matches for the keyword password. Now, the reason we're doing this is because within configuration files, many services or software, pieces of software, will typically store credentials, may typically store credentials, and the way they store them is by listing out the username and the password, and that's why we're searching for the password string. As you can see, this is quite difficult to actually go through because of the sheer amount of results that are going to be output. What we can do, however, is fine-tune our search to a particular directory, or limit our search to a particular directory. Now, the configuration files on Linux are typically stored within the etc directory. So if we limit the results to the etc directory, you can see that the results are much fewer now, and we can go through the results to identify whether we can find any legitimate credentials. In this case, you can see that we can't find anything useful here, so nothing within any configuration files. We already know that we were able to obtain the MySQL root credentials by taking a look at the WordPress config file in the previous video during our initial exploitation. So again, we can do that as well. You want to check as many directories as possible where you typically have passwords being stored. So var www HTML, and of course this is going to be recursive, so it will display quite a bit of data. And of course, as you can see, that is quite extensive in regards to the results that it outputs. We can limit it to WordPress so that we only limit the occurrences of the string password to the files within the WordPress directory. So I hit enter. You can see it's reduced it slightly. And of course, WordPress contains quite a few occurrences of this, but we're going to be looking for the actual value, the actual password, as opposed to the specification of the string here. So again, in this case, it's quite difficult to read. but by performing an analysis of what services and software is running on the target system, you can go through, or you can identify where credentials are stored, as we did in the initial exploitation video. So again, for example, we were able to identify that under the var html WordPress directory under WordPress config.php, we were able to identify the MySQL root user credentials, and you can see we have the database user, which is root, and the password. So let's actually copy this, and I'll just exit out of there. And if we list out the current users on the system, we can see that we have the user Steven, right? So we can pretty much try and laterally elevate or horizontally elevate our privileges to the user Steven, even though we know that this user is not an administrative user or a user with administrative privileges. We might find some data within their home directory. So we can always try that. So the way we can actually do this is, if you remember, we were able to identify the SSH credentials for the user Michael by logging into the MySQL database, and then of course we were able to dump the database the data from the WordPress tables, or the WordPress user table, and we were able to get their WordPress credentials. However, for the SSH credentials, we were able to perform a brute force with Hydra and identified the credentials for the user Michael. However, we did not do the same for the user Steven. What we can try and do is try and identify whether there is some form of password reuse here. So we can try and crack the password, the WordPress credentials for the user Steven, and see whether we can log in via SSH, or just authenticate with that user account with the password that we can that we will crack. So we can log in. So we'll say MySQL user is root, and the password we will paste in, because I copied it. There we are. If I say show databases, you can see we have the WordPress database. I'm going to say use WordPress, and then show tables, like so. And then we say select from WordPress users, and I hit enter. You can see we have the MD5 hash here for the user Steven. We can crack this MD5 hash quite easily with John the Ripper. John the Ripper is a password cracking utility that comes prepackaged on Kali Linux. And the way I'll do this, I'll just open up a new terminal here, and I'll essentially say sudo. Well, before we do that, we actually need to save this hash, because John the Ripper requires that we specify the hash within a file. So I'll use Vim, and I'll just create a file called hash.txt. And I'll paste in the hash here. Now, whenever you're specifying a hash that's going to be read by John the Ripper, you want to also provide the username of that particular password hash. So this can be done by specifying the user, which in this case is Steven. You then want to use a colon, and that's how you want to save it. So I'm going to write and quit. And now we can say sudo John, and then we specify the file that contains the hash. And the reason we're not specifying the format is because John the Ripper will automatically detect what hash it is and then crack it accordingly. We then need to specify the word list to use to perform the brute force password cracking here. And we are performing a dictionary attack in this case. So we can again utilize a comprehensive word list like the RockU word list, as we did in the previous or the initial exploitation video. So we'll say user share word lists. And under RockU, the name of the word list is rocku.txt, right? We hit enter. I'm just going to provide my password here, and it's going to begin the password cracking process. And it looks like it found the password for the user Steven. So you can see it's saying the password is pink84. So we can try and authenticate. Let's see whether this will actually work. I'm just going to copy it here without the spaces. So we'll copy that. If I now, I'm just going to drag this slightly here, and let me just exit from the MySQL database. If I now want to authenticate with the user Steven, I can say su Steven, and then I paste in the password that I was able to get, and it looks like that worked. If I type in the ID command, you can see we're logged in as the user Steven, so that was successful. So it looks like we were able to exploit the password reuse, or we were able to exploit a password reuse misconfiguration, or vulnerability rather. So this is one thing that a lot of users do, is they'll typically use the same password for multiple accounts. In this case, they've used the same password for their WordPress account as well as their Linux account here. So I'll just spawn a bash session. So I'll say bin bash I, because we're currently within a Bourne shell. And there we are, Stephen. So I'll just head into their home directory. Let's see whether we can identify any files within that directory. We can't. If we say history, we can see that again, it's just for the current session. So I'm just going to close that tab. And we're back here on the user Stephen. So again, we've been able to identify the credentials for 2 users on the system. One of them is Stephen, the other one is Michael. The next step is to obtain root privileges. So what we can take a look at now is how to use automated enumeration tools, automated local enumeration tools for Linux systems. So the first thing I'll do is I'll just head over into my TMP directory. Whenever you're working with the Linux system, you never want to store your scripts and files within a directory that is frequently accessed by users on the system. So the TMP directory is a great option. You can also opt or create other directories that again are clandestine as possible. So the first utility or tool that we're going to talk about is a tool called linenum, right? So I'm just going to perform a quick Google search for it here. And I'll just open up the GitHub repository. The link to this GitHub repository will be in the documentation for this video. So linenum is a local enumeration tool that automates a lot of the enumeration checks that we typically perform, but it also identifies vulnerabilities that we can exploit to elevate our privileges, etc., etc. So you can clone the repository and you need to transfer the linenum bash script onto the target system. I have already cloned the repository, so I'll just open up a new tab here and I'll navigate to the directory where I stored them locally, which is going to be on my desktop. There we are on my desktop and under a folder called Linux enum. And within this folder, I have the linenum bash script here. I'll now use the Python module simple HTTP server to set up a local server here on port 80 that will serve these files. And then we can transfer or download these files onto our target system using the wget utility. So I'll say sudo python m simple HTTP server, and we'll say port 80. We hit enter. I'll just provide my password here, and you can see it's serving HTTP on my Kali IP on port 80, right? So I can now say within the temp directory on the target wget HTTP, I then specify my Kali Linux IP address, which is 192.168.2.21. And then I specify the file that I want to download, which in this case is going to be linenum.sh. You can see that that's saved successfully. And on the web server side here, you can see that the get request was successful because we get the 200 status code there. So what we can do now, let me just terminate my server there, and I'll just clear the terminal so we can see what's going on, and I'll just bring this to the side here. So we need to provide the script with executable permissions. So if we list out the contents here, you can see it's saved successfully. So we'll say chmod +x linenum.sh, and then we can execute it by saying linenum.sh. We hit enter. It's going to begin enumerating all the important information in relation, or that's useful for privilege escalation. So you can see, number one, it outputs the kernel information as we were able to do manually in the initial access video or the initial exploitation video. It also displays the kernel information in depth here and the version of GCC installed. That will be useful in a few seconds. We get the host name of the system, the current user group, etc. And again, all the groups available on the system, the contents of the password file. And we also identify something that's very interesting here. So it says that we can sudo without supplying a password. All right, so this brings us to our next privilege escalation technique, which is exploiting SUID binaries or sudo permissions. In this case, it looks like that for the user Stephen, a sudo permission has been set by the administrator, and the permission is listed here. So it looks like the user Stephen can run the Python binary or can run Python as the root user without providing the root password. So that means we can potentially use this as our privilege escalation attack vector. primarily because if we can essentially find a way of spawning a shell within Python, remember it's going to be executed with root privileges, so that means we should get a shell with root privileges. So again, it says right over here, possible sudo pawnage. So we can, in order to exploit this, we can utilize a resource called GTFO bins. This is an online resource, and this link will be in the documentation. That again, you can see it actually gives you a very good description here. GTFO bins is a curated list of Unix binaries that can be used to bypass local security restrictions in misconfigured systems. So if we search for the binary that has been misconfigured, which in this case is Python, we'll just click on Python here. And we're not looking for a typical shell. We're looking for, let me find it here. There we are. We're looking for a sudo, right? Or a sudo or root shell. So you can see it says if the binary is allowed to run as super user by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate or maintain privileged access. So in order to exploit this, we can say sudo python. So we're launching it with sudo, and remember we don't need to provide the root password or the root user password there. And then we're essentially saying import os.system and then execute bin. We can then execute a shell session. And because we're executing it with root privileges, we should get a shell with root privileges. So in order to exploit this, I'm just going to again go down here, and then we can execute it. But instead of getting a normal bourne shell, we'll spawn a bash shell here. We hit enter, and we've obtained root access as it says right over here. So if we type in ID, there we are, root access, and we now have taken complete control of the target server. And we have done this by exploiting a misconfigured sudo privilege for the Python binary. This is a very, very common practice that you'll find on tons of servers where the administrator does not want to provide a particular user with privileges, with complete administrative privileges, but restricts administrative privileges to one binary or to one script. And if misconfigured, we can exploit it to obtain a root shell as easily as we just did. So this is the second technique that I wanted to highlight. The final technique is going to involve utilizing a kernel exploit. So again, the reason I'm taking you through all of these techniques is because again, you need to have an understanding of how to utilize multiple techniques, and you shouldn't rely on one because systems are configured differently. Now, as I said, what we'll do is we'll just go back into the user Steven here. And again, I'll just spawn a bash session. There we are, and we're back into the user Steven. So the next step is going to involve performing kernel exploitation. All right, so let's take a look at kernel exploits. Now, when it comes down to kernel exploits, there's really two pieces of information that are vitally important to the process, right? And that, of course, is going to be the distribution release version or the distribution itself. So, is the target running Ubuntu? Is it running Debian? Is it running Fedora, Red Hat, etc., etc.? And secondly, and the most important of all, is the kernel version. Now, it's important to note that kernel exploits or privilege escalation via kernel exploits is not really a recommended technique, primarily because the Linux kernel is the core of the operating system, and a kernel exploit essentially interacts with the kernel. Now, the problems that can arise are twofold. Number one, this can cause issues with the system stability. So, there may be a kernel panic when using a kernel exploit. This can consequently lead to data loss or unexpected shutdowns. Secondly, kernel exploits are really not stable in regards to the actual execution on the target. And of course, when I talk about stability, I'm referring to the fact that kernel exploits typically only work for a specific kernel version. So you have to make sure that you're running the correct kernel exploit, or again, you can cause unintended harm really to the system. And of course, that can again consequently raise red flags or alert system administrators or security analysts as to a possible intrusion or a possible activity on the target system that is typically not expected. That being said, as I said, when on the Linux target, you can enumerate this information. For example, if I wanted to display the kernel version, I can type in uname r, and this is the exact kernel version that's running on the target. So realistically speaking, we should only be able to, or we should only run kernel exploits for this particular kernel version. And then, of course, the other piece of information that's vital here is the actual distribution and the distribution release version. In this case, you can see it's Debian 8 and the release version is 8. So, of course, we know that the target is running Debian 8 and the kernel is 3.16. All right, now, when it comes down to kernel exploits and privilege escalation, as I've said, there's lots of ways we can sort of identify exploits for this particular kernel. However, there is a tool that we can utilize to automate this process, to automate the process of identifying kernel exploits for our particular target. And this tool is the Linux Exploit Suggester, all right? And the GitHub repository will be in the documentation for this video. So you can head over to the GitHub repository. It is essentially a bash script that needs to be run on the target system. And what it does is it actually, it essentially gets the information that again is relevant, like the distribution release version and the kernel version, and then essentially provides you with a list of vulnerabilities or exploits for that particular kernel version, right? Now, I also need to point out that kernel exploits really do not have a high probability of success unless, again, the exploit has been tested and you've been able to confirm beforehand that this does work. Now, what I would typically recommend whenever you want to run a kernel exploit on a target system, I would recommend setting up the same system on your virtual lab or on your virtual network. So, for example, in my case, I would download Debian 8 and ensure that the kernel version is 3.16, and then run the kernel exploit on that system first before running it on the target system. Firstly, to verify that it is working, and secondly, to confirm or to verify that it's not causing any issues, right? So we can use this script. You can download it by using the wget utility and the command here, and that'll save it for you. In my case, I've already downloaded it, so I'm just going to open up a second terminal here, and this is on my Kali VM, so I'm just going to navigate to where I've stored the script. This is under Linux enum. And you can see that we have it there. This is the script name. This is les.sh, is an acronym for Linux Exploit Suggester. So that's the actual script name. If you actually download it using wget or this particular command, as you can see, it saves it as les.sh. All right. So now we need to transfer it over to the target system. So again, I'll just use the Python module, simple HTTP server, to set up a simple web server to host these particular scripts. And again, I'll just hit type in my password. There we are. So that's serving. I'm currently on the temp directory on the target system. So if I list out the actual contents of this directory, we only have the lin enum script. So we can say wget and then http, put in your Kali IP. So I'll just type that in, and then we say les.sh. That's going to download it for us. There we are. So that's saved. And I'm just going to terminate that, and I'll close this here. And I'll now provide the script with executable permissions. There we go. And then I'll execute the script like so. I hit enter. And you can actually see that it's actually completed, providing the result. So let me just go through the way this works. All right, so firstly, it will gather all the important information it needs to actually perform the scan. And that information is the kernel version, which in this case we know is 3.16.0. The architecture of the operating system. In this case, we know that the target is running a 64-bit version of Debian 8. As you can see, the distribution is Debian. The distribution release version is 8. And it then gives you, a summary of how many exploits exist. So we have 76 kernel space exploits and 48 user space exploits, and then it displays the exploits for this particular kernel version. Now, whenever you're using the Linux Exploit Suggester, you want to look out for the exposure. The exposure tells you the probability of success when using this particular exploit. So you can see for the first few exploits, you can see that the exposure is highly probable, which means there's a high chance that this might work. And you can see it for the second one, and for the third one, you can now see it's less probable, and it just continues. So the way the script works is that the vulnerabilities or the exploits with the highest probability of success are going to be displayed first, and then the ones with the least probability of success are going to be printed out last, right? Or after the ones that are highly probable. The information displayed is fairly helpful because it provides you with the common vulnerabilities and exposure ID or code. That's the CVE code, as you can see. That allows you to actually research more about this particular vulnerability. The exploit is provided here. You can see it's the dirty cow exploit. It provides you with a reference link for this particular exploit and how you can exploit this vulnerability. As for the tags, this is very important. It tells you what system or what distributions and kernels this exploit will work on. So in our case, you can see that we're pretty much good to go because it supports Debian 7 and 8. Also Red Hat Enterprise Linux, and then displays the specific kernel that it will work on Red Hat and also on Ubuntu. So you can see Ubuntu 16.04, 14.04, 12.04. It then provides you with a download link for the exploit code itself, which you can then download, compile, and transfer over to the target and then execute. So what we can do is, let me just copy this particular exploit name and let's perform some research on it just to see how this works. Now, I need to point out before we get started with this that I have, again, worked with this system before, and I've run, multiple kernel exploits, and only one or two were successful, but not they weren't able to provide me with elevated privileges. So in the case of this box, I would not recommend running any kernel exploits. I'm just taking you through the process of how this is done, right? So we head over into our browser. We have the dirty cow exploit, and you can click on the exploit DB link, right? Which I believe corresponds to the link provided here. No, this is 40611, but it's the same exploit, I believe. I'm just going to wait for the exploit DB link to actually open up. All right, so the exploit DB link is opened up, and you can see this particular exploit targets the Linux kernel 2.6.22 and lower than 3.9. So we are in the within this range here, and it gives you an idea of what it does. So it's exploiting a race condition and provides us with privilege escalation. So the way the dirty cow exploit works is it essentially creates a new administrative user account on the target system, and the default user that it actually creates will have a name of Firefart. Now you can actually download the exploit code and change the actual name, the username, to whatever you want. Remember, you want to be as clandestine as possible. So as I said, it actually allows you to create a new user account with administrative privileges. And again, you can specify your own password. Once the exploit has run successfully, you can then switch to that administrative user, or you can SSH into that user account. So this is a really cool exploit when it does work, because it can allow you to create a backdoor user that again has administrative privileges, and you can then utilize that as a backdoor, and you can again authenticate to that user overtly using SSH. So in order to use it, we need to download the exploit code. So you want to click on the download link here. And what I'll do is, let me just open up a new terminal window. And I'm just going to wait for this to bring up the download prompt. For some reason, the exploit DB site has been slightly slow today, but it should actually pop us up. There we are. You can see we have the download prompt. I'm going to hit save file. I'm now going to move the exploit code from my downloads folder, because that's where Firefox saved it, into my current working directory. As you can see, we now have it here. It's 40839.c. So I'm just going to rename this to exploit.c. So let me just get the correct name here. So 40839.c, and we'll rename it to exploit.c. Right. So now that that is done, we can actually move ahead to the compilation phase. Now, the exploit DB link here actually gives us instructions as to how we can compile this. Now, I would typically recommend compiling the exploit code on the target system if GCC is installed, because again, this is a C file and we want to compile it into a binary. So the target needs to have GCC installed. In this case, we know the target has GCC installed during our local enumeration section, or during the local enumeration section. So what we can do is, I'm just going to again use the simple HTTP server to host the exploit code, and then I'll download it onto the target. We'll then compile it and run it. All right. So simple HTTP server, and we hit port 80. There we are. And now I'll just use the wget command, type in my Kali IP, and exploit.c is the file we want to download. That downloads successfully. So I can now close that up. And if we see, we display the actual contents of this directory. You can see we have exploit.c. So to compile it, we need to use gcc and then the pthread and lcrypt flags for successful compilation, primarily because this particular script or this particular exploit utilizes the pthread libraries. As you can see here, pthread and lcrypt, if I can actually find it. Well, we have crypt here. There we are. So there we are. So that's why you need to provide the flags. So I'm just going to copy this here. And of course, we want to substitute the names here of the C file. In our case, the name of the C file is exploit.c, and we will output it into a binary called exploit. All right, so I hit enter. It looks like compilation was successful. If I list out the contents now, you can see we have the exploit binary. So let's provide it with root or executable permissions. And I'll just say chmod +x exploit. If I list that out now, you can see we still have it here and the permissions have been set correctly. This particular binary is owned by the user Steven, primarily because we're working with that user. So the way, as I said, this exploit works, we simply need to execute it. We can provide a password, but it should prompt us to provide a password for the user account, the root user account that it will create. Again, you can also customize it. So if I go into the exploit.c code, we don't have Vim here. So let me just use nano exploit.c. You can see that you can change the default username to create by changing the salt value, which again is set to Firefox. So you can change that to whatever username you want. You can also change the username. I think there is a field here that allows you to change the actual username. There we are. So user.username, you can change that from Firefox to whatever you want. You can also change the user info and the user shell if you want. All right. But in this case, we're not going to play around with that. We're just going to say exploit. We hit enter. It's going to say that the etc password file has been backed up to the temp directory, and the backup file is called password.backup. So this is useful if you ever want to revert to the previous password file. And it's going to ask us to provide a password for this new user account that we want to create. I'll just say password. I'll hit enter. It's going to begin the exploitation process. But as I said, with this particular box and with this particular kernel, this exploit doesn't work because it will not actually create the user. But again, as I said, I'm taking you through the methodology of utilizing a kernel exploit here. So I'm going to wait for this to complete running, and then I'll actually confirm to you that this did not work. All right, so the exploit has actually completed running, and you can see that it's going to tell you right over here. Let me just see if I can identify that. There we are. So it's going to say done. Check the etc password file to see if the new user was created. You can then log in with the username Firefox and the password that we specified. So again, if I say cat etc password, you can see that it did not add the Firefox user, primarily because, as I mentioned earlier, this exploit doesn't work on this version of Debian, or rather this particular kernel. It looks like it was patched and that user wasn't created. However, as you can probably tell, this is not a silver bullet when it comes down to privilege escalation, and we were able to actually utilize the Python binary, or Python rather, primarily because it had the particular sudo permission set that allowed the user Steven to execute it with root privileges and not provide a password, and that was a much more direct technique or vector that we utilize. So again, all I need to do in order to obtain root access is just copy this command here. And again, I need to be as a user Steven, because that particular sudo permission has only been set for the user Steven. I provide the bash or the actual shell that I want. I hit enter, and you can see we have root privileges now. So that's much more of a better technique, because we're essentially exploiting misconfigurations. As I said, kernel exploits do work quite a few times on Linux, but when dealing with new or modern systems or modern distributions with kernel versions over 4.5, kernel exploits are far and few in between. So you really need to have a well-balanced approach in regards to what vectors you target. Now, when we talk about privilege escalation on Linux, there's plenty of other techniques. I'll probably be covering them in their own videos. You can elevate privileges by exploiting misconfigured cron jobs. You can elevate privileges by exploiting various Linux services, so on and so forth. But hopefully with this video, you have an idea of how you can go about elevating privileges. And what it comes down to essentially is understanding how your target has been configured, what the limitations are, and then of course essentially strategizing what vector you want to use based on the target configuration. That being said, that's going to be it for this video, and I'll be seeing you in the next video.